Hello children, hope you are fine and you are understanding the concepts and topics. We have given so much time for this chapter 1. For that, time by time I have uploaded the videos for that and audios for that, and now we are just on the finishing line of this chapter. That is our last topic for this chapter. It is laws of exponents. I know that you have done these laws of exponent in class 8 also. So it is just an extension to those laws of exponent which you have done in class 8. For example, briefly I'm explaining you the laws of exponents. When the bases are same and multiply sign is there, we add the exponents. Similarly, if the bases are same and divide sign is in between the bases, we subtract the exponents, and minus exponents are changed into positive exponent by taking the reciprocal of that. Similarly, we use the laws of exponent in this way, as anything raised to power 0 is taken as equal to 1 and many more than that. So let's have certain examples for that. For example, here we have taken the example. This is our first example as 8 raised to power 1 upon 3. Then second example as 27 raised to power minus 1 upon 3. Third example as 64 raised to power 3 upon 4, and fourth example as 625 raised to power minus 1 upon 4. So we are going to do these sums first, step by step. After that we'll take the laws of exponent briefly. So here we have our first part as 8 raised to power 1 upon 3. Children, you can put the brackets in order to separate the exponents. And moreover, you must take care of this, that how do we write this? The number is to be written in a proper way and exponent is written somewhat smaller over there. Okay, so let's first find the factorization of this number. 8, 2 fours the 8, 2 to the 4, and 2 ones the 2. So we have obtained here 2 raised to power 3 whole raised to power 1 upon 3. And if you see that, it will be equal to, now here I am using the law of exponent over this part, any number raised to power m and whole raised to power n. So we multiply both the exponents. So here 2 was the base and m was 3 and n was 1 upon 3. So can you see the cuttings over here? So you are left with 2 raised to power 1, and you know very well that 2 raised to power 1 is 2 only. So this is the answer for that. So this give us answer for the first part. So now we are done with the first part. Let's have the second part after that now. Second part is your 27 raised to power minus 1 upon 3. So we are writing this as 27 raised to power 1 upon 3. It is in negative, so minus 1 upon 3. So 27 raised to power minus 1 upon 3 is our given number. Now can we factorize 27 over there? Yes. It will go at the table of 3, 9's the 27, then again 3, 3 to the 9, then with 3 again, you'll get 1. So, the factors are 3 raised to power 1, 2, 3 and whole raised to power minus 1 upon 3. And again, using the same law as we used in the upper part, multiply the exponents over there, but here after the cancellation you will get the powers in negative. 3 raised to power minus 1. So do the reciprocal of that. Reciprocal means like this. So do the reverse of that. It is 1 upon 3. So this is your answer. Now second part is also done. So let's have the third part after that. What is our third part? Third part was 64 raised to power 3 upon 4. So let's have that part. 64 raised to power 3 upon 4. Now see children, we can factorize 64 in many ways, like you can go with 8 also, or we can go with 2 also. 32, then with 2, 16, with 2, 8, with 2, 4, with 2, 2, and with 2, 1. So how many powers? 1, 2, 3, 4, 5, 6. So here we have obtained it as 64, we have obtained as 2 raised to power 6, and outside is 3 upon 4. So you will get it as 2 raised to power now 6 into 3 upon 4. Is there any cutting? Yes, 2 to the 4, 2 3 the 6. So you got it as 2 raised to power 9 upon 2. Now this is very very important. What answer will you get here? You have got it as 2 raised to power 9 upon 2. Can we easily write it in any form? Yes, you can write it as, how do you write 2 raised to power 9 upon 2? For 1 upon 2 we'll write it like this, and power 9 can be written here. So this is the real representation for 2 raised to power 9 upon 2. One more time, you can see here 2 raised to power 9 and half outside. 2 raised to power 9 and half outside. How do we write this? This can be written as, for half you are going to put under root. So under root we are putting here, and 2 raised to power 9 you can write like this. Okay, so this was very very important concept, because it has come in fractions which we cannot cut easily, so that's why we represented it over here. Now let's take a few more example for that. Now if we have the parts like this, suppose our next part, fourth part is 625 raised to power minus 1 upon 4. Again, do the factorization of 625, students. It will be easily divisible by 5. 125 with again 5, 25 with again 5, 5, and with 5 again as 1. So we have got it as 5 raised to power 1, 2, 3, 4. So 4 and whole raised to power minus 1 upon 4. Use the same law of exponent for powers. It is 4 into minus 1 upon 4. Cut 4 and 4 easily, and you will get it as 5 raised to power minus 1. I told you that how do you change negative power? It can be changed as 1 upon 5. The law used here is a raised to power minus n is equal to 1 upon a raised to power n. And in previous part the law was a raised to power m whole raised to power n is equal to a raised to power m into n. I think we should highlight these laws such that you can easily understand these. So this was our first law, and this was our second law. So these are the laws of exponent which you can easily observe over there. Alright, and now after that, if we have mixed type of parts like this, suppose we have parts like this, 25 raised to power half into 343 raised to power 1 upon 3, and upon, if we have 64 raised to power half, and that is in negative. Again, it is so easy to do. How can you write 25? It can be written as 5 raised to power 2 into half. How can you write 343? 7 into 7 into 7. How many times 7? 3 times. And into 1 upon 3. And upon 64. 8 raised to power 2 into minus half. Cut all the powers which can be easily cut. So this is equal to 5 into 7, and here 8 raised to power minus 1 was there. So if we take it up, it is 8 raised to power positive 1. So now you can easily multiply 8 5 the 40 into 7, and which gives us 280 as the answer. So this was a little bit more extra concept about powers or laws of exponent. So now after that, one more type of question. If we have this type of question, suppose 11 raised to power 3 upon 4 divided by 11 raised to power 1 upon 2. How will we go for that part? Suppose this is our, this was fifth part, and now this is our sixth part. How do we go for this? Can you tell me which law of exponent can be used? Bases are same and divide sign is there. So what we can utilize over there? We can utilize the law of exponent as bases were same. So base is written only one time, and powers now 3 upon 4 minus 1 upon 2. Can we take can we take any LCM over there? Yes, we can take LCM over there. 11 can be written as the same, and LCM is 4. Now it will come 3 and 2 to the 4, so will come 2 over there. So it will be 11 raised to power 3 minus 2 upon 4. And children, can you solve this part now? It will be 11 raised to power 3 minus 2 is 1 upon 4. And as I told you earlier, how can we write it in unroot way only? Now it can be written as like this 11, and it represent unroot means power as half, but we have here 1 upon 4, so we can write 4 here in this. So just like cube root, you used to write 3 here, like for the fourth root we can write here 4. So we can say that a raised to power 1 upon n, we can write it as equal to a in the root and nth power over here. I hope I am clear for this. Similarly, a raised to power 1 upon m can be written as a and mth power over here. So this was more about exponent. So very easily you can apply the laws of exponent here. For example, you can see on this page also that how easily you can do these powers if you know the prime factors and laws of exponent. So this was all about our laws of exponent topic. The simple problems we have taken first, you can have a look, and after that a bit complex problems in which multiplication was also there, so we have taken that concept also. Just take care that when negative power are there in the denominator part, if you take it up it will become positive. Here 8 raised to power minus 1, it will become 8 raised to power plus 1, and simply multiplication was there, you can do that. And here nth, for the nth power, a raised to power 1 upon n, how can you write it with the help of 1 root? It can be written like this: a root, and it will represent with power n here in this. Similarly, a raised to power 1 upon m can be written as a root and m over here. So I hope we are done with our this exercise also, and we are able to finish this chapter. I'll upload the worksheet for that same today only. Thank you so much, and hopefully after this chapter we are going to start the next chapter as chapter number 12, that is Heron's formula. Okay, thank you.